Hello.
Hello. We're just waiting for folks to join. And the host should be giving you, do you have the ability to share your screen?
I do.
Oh, good.
So I think we're up against the headliners on this session. So I'm curious to see how we do on attendance.
Yeah, I was just asking what the usual attendance is. It's anywhere from 30 to 85, 20 to 85, something like that. And we're being recorded at the moment, just so.
So should avoid blurting out profanity lest it be captured for the
Yeah, probably a good idea.
all of it. Glorious title slide up there. How exciting. All right, looks like folks are still trickling in, so we'll give folks a few more minutes. So as we all become more adept at the Zoom conference, I feel like there are certain things that we know are going to happen, right? The host is always going to say, I'm going to give people a few more minutes as I watch them trickle in, because you don't have that cue of the hallway conversation sort of quieting down. And at some point, I will be forced to ask, can you see my screen? I suspect that one of the things that remains the same is that terror of the empty mic. So you find yourself standing either in front of the room or in front of your camera, just yapping as I'm currently doing at you. Thanks. The one thing I have come to appreciate is the back channel. So the ability to do simultaneous chats, do a little bit of direct messaging contact. So I don't know about the rest of you, plenty of things that I will not be carrying away from our year plus in quarantine with any sort of joy, but definitely been some practices that I'm excited about. And I think some of those long-term are going to lead us to some better conferencing experiences. Give maybe another 15 seconds, then we're going to dive in. Hopefully you are at the right place. We're here to talk about leveraging some of the OpenSimon toolkit in service of evidence-based improvements to courseware, or a different way to think of this is leveraging data in the service of continuous improvement of learning. I know that we are up against some headliners during this time slot. Carrie Brown from IMS and CEO of Unizin. So it looks like there may just be 15 of us. Anybody that sneaks in after the fact can catch up. So welcome, and thanks very much for having us. My name's Norman Bier. I'm at Carnegie Mellon University, where I wear a couple of hats. I am the executive director of a project called the Simon Initiative, and I lead an effort called the Open Learning Initiative, OLI. I'll be talking a bit about both of those roles. Erin, do you want to introduce yourself?
Yeah, thanks, Norm. I'm Erin Czerwinski. I am manager of learning engineering at the Open Learning Initiative, and I'm manager of the larger technology enhanced learning ecosystem, specifically the OpenSimon toolkit for the Simon Initiative.
And we are really thrilled to be here. I think that Carnegie Mellon is not traditionally, has not been a part of Unizin efforts. We're not a part of the consortium. And so it was really exciting to be offered an opportunity to engage with this, this summit, particularly in the context of Unizin opening up access to their data platform in bigger ways. And so we're really excited about the opportunities of collaborating long-term. We're hoping this is a start of a conversation. And it's also exciting because many of the things that you'll hear us reference during our talk, you'll see some opportunities to get more detail on tomorrow during the keynote. Ken Katinger is one of our colleagues at the Simon Initiative who will be taking a deeper dive into leveraging some of these approaches from a research context and thinking about what it means for our instruction. So what you're going to be seeing today, we're going to be talking a bit about data and analytics generally. We're then going to want to talk to you a bit about the Simon Initiative and our learning engineering approach. And from there, what are some of these tools? What are the data? What are the analytics that are available? How might you use them? Give you some case studies, some examples of this stuff in context, and then hopefully move on to a chance to talk a little more about how you can more directly engage with this work. In the presentation description, I know that we promised you a small group workshop or a set of small group activities. Erin and I have found that those small group activities have not translated well online. We keep trying, we haven't gotten it right yet. And so we're more likely to end up with a discussion than breaking you out into small groups. And we hope that you'll take that as an opportunity and an invitation to come visit us, and we can have some in-person small group workshops when in-person becomes a thing that we all do. As I dive in here, if I could invite you to jump into the chat, let me know who are we talking with, where are you from, what kind of work do you do there? And from there, we're going to dive in. So some questions that I'm hoping to get out of you as we dive in is to sort of understand at this point, what are the types of data and what are the sources of data that you currently have access to? Where are you pulling data from? How are you currently using these data, right? So you've got lots of places that you can pull data. We've got lots and lots of different things that fall under the heading of learning analytics. What types of analytics are you actually using? What's available to you? And maybe the big question, what's the stuff that's missing? What are the things that you wish you had? You're certainly welcome to contribute those into the chat, but I'd also be thrilled if anybody wanted to jump in and make a comment, raise your hand, and share answers to any of these. Feeling like a shy group today? That's okay. It's part of the challenge of an afternoon session. I think folks are, sometimes less anxious to jump out and chat. So we've got Tableau for visualization, which is great. And I think we're starting to see a little more use of Tableau at CMU. Interestingly, not from our learning science department, but rather from our central administration has been encouraging that. So it looks like we are well representing the Commonwealth of Pennsylvania. Text analytics for discussion is grand. Yeah, I think that there's this notion of how we start more systematically gathering, sharing our data, creating a data lake to which others can have access, in which we can take a more thoughtful approach in transforming and pushing downstream, to stretch the metaphor, is a point that's pretty important. And how we actually translate these data and these analytics into action is important. So often when we have these conversations, as folks start citing what constitutes their data lake, we see some of this showing up in our discussions. Obviously, the kinds of data that we can pull out of our LMS, which often gives us opportunities to dive a little more deeply into quizzes, into student participation, into discussion forums. When we are really having a lot of success, we're able to tie some of these things into our larger student information systems. How do we start to understand demographics? How do we understand progression? How do these pieces contribute into our broader portrait of student success? And as Megan notes here, how we're able to then tap into advising systems, whether this is extracting data or whether this is pushing this data out in ways that allow our advisors to be actionable. What we haven't heard a lot about, and what I think has been interesting about the pandemic, has been this opportunity to more consistently gather paradata about what's happening in these classrooms. Here at CMU, we've needed to be more thoughtful in understanding where are we doing fully remote sessions, where are we doing hybrid sessions, what's happening in those sessions that must be face-to-face. None of this has been in service of the kinds of deep learning research that we usually engage in. All of this has been very pragmatic in terms of the pandemic, but I think that information has been pretty important. And as we start to look to these larger concepts of institutional data lakes, we now start to get into the dirty and scary world of metadata, right? So how do we start to understand and capture the information about our information? Normally during these sessions, no one has put this out, we talk about clickstream data, we talk about diving in deep and getting every click that the learner makes. But one piece that we don't often talk about, and one piece that we're pretty obsessive about inside the Simon Initiative, are data that we think about as learner interaction data and the larger semantic context in which those data operate. So those are the pieces that most of my discussion is going to be talking about today. And this aligns with a slightly different vision of how we think about learning analytics or student success analytics. I think that an awful lot gets lumped into those categories. So, when we start to drill in and understand what do these different analytic systems and what do these different analytic methods show us, when we look under the hood, we're sometimes looking at understanding how students are engaging with our materials. Others provide opportunities for understanding progression and broader portraits of student success. Where we tend to focus at CMU is in trying to understand learning, really drilling in deeply to identify those changes to student knowledge state and how we're able to influence those. And so this is really these areas of how we leverage learner interaction data and semantic context in the service of analyzing and improving learning is really the focus of our work. And it's going to be a theme in our talk. Why do we have this emphasis? Well, in part, I try to provide this emphasis to distinguish some of the work that we're doing from other really well-established work, really interesting work. But I also do it because it has a real historical bent in terms of how we understand and think about this project that I talk about as the Simon Initiative, this project that we think of as learning engineering. And so I want to talk a little bit about that. One of the things that's interesting about Carnegie Mellon is that we don't have a college of education. And yet we've got this really rich 50-year-old and longer tradition of researching learning and of focusing our efforts on how we can think about improving learning. If we have to pick a specific point at which CMU gets involved with it, it's with this man. This is Herb Simon, probably best known for his work in artificial intelligence, potentially for his work that earned him a Nobel Prize in economics around organizational behaviors. But at CMU, one of the many things that we know him for is this deep interest in and prodding of the university community in improving post-secondary education. His own sense was that so much of the work in theory that was happening around learning in his time was not scientifically based. And he really wanted to encourage a more scientific foundation, which has influenced how we think about this work. But he also wanted to encourage his colleagues to take this work as seriously as he did, that we needed to begin to think about post-secondary improvement as a research activity, but a research activity that we treat with the same seriousness, the same authenticity as research in our own domains. And so if we think about CMU as not having a college of education, Simon's challenge to the rest of Carnegie Mellon is, how can we treat the entire university as a college education? How do we take every classroom and turning it into a learning laboratory? 50 years later, CMU has had an awful lot of success at combining learning science with educational technology, of really advancing evidence-based approaches. But what we've learned is that, like other research projects, without a natural home, we often find ourselves not interconnecting as well as we might, not seeing these kinds of projects leveraging one another's work, and not always seeing the good research that's emerging from these efforts being used to actually improve learning for students. And so the Simon Initiative was launched with the goal of really providing an umbrella over this work, finding ways to get it out into the world so that we can have a better impact on student success, and hopefully accelerating the good impacts that we've already seen. But it's a pretty diverse set of work. And so we also need some kind of framework for understanding what's common across it. And as we think about that, we go back to a very Simon-esque notion, and that is, where does learning happen? Well, if we think about learning as literally being that change of knowledge state happening inside of a brain, then it's not something that we're able to observe. We're going to think about this as a research activity, can't yet peer into the brain. And so to research it, we're stuck building models of what we think is happening inside of that brain. And further, we're stuck taking those models and connecting them to actual observable practice. And it's through those observations that we're able to validate our models, we're able to refine them. This is a concept that we talk about as learning engineering. This notion that we're able to use these models of learning to first take work coming out of our theory to design our model, and then in turn, design and build new kinds of instructional interventions. One key piece about these interventions is that they're instrumented. And so we're able to take the data emerging from these interactions, use them to validate our model, but also use them to refine and improve the innovation itself. We often talk about this in an online context, talk about it in a technology context, but the reality is that any kind of learning experience can be instrumented. We've got what we talk about as an experimental classroom at CMU, where we're able to put this work into practice in terms of new face-to-face innovations. So we've got one key part of a virtuous cycle, with the second being that in the aggregate, we're now able to take these data, push them back over to our colleagues in the learning sciences to advance fresh discoveries. And so we are able to simultaneously improve learning while improving our understanding of human learning. And this is really at the heart of the learning engineering approach. You've heard me use this idea of a learning model, and you're going to hear it pop up a lot in this talk. And so I think it's worth unpacking just what constitutes that model, because on the one hand, frequently I've got colleagues who are building very advanced statistical models that are intending to capture that change of knowledge state. But a learning model can also be very simple. We're able to take the collection of skills that we're hoping students can attain, the sets of activities that we believe are going to get them there, and our forms of assessment to understand where success is happening and where success is not. By making these models explicit, by trying to capture for a given learning experience, what are our skills, how do these connect activities, and how are we assessing it? Sort of straight off the bat, we have this mechanism for understanding learning and for making it more robust. In this context, note that we've got a model where we're teaching some things that we're not assessing. We seem to be assessing some things that we're not teaching. And it may turn out that through investigating, we may have some skills that we've missed. So an awful lot of our conversations in Simon and an awful lot of our tools are built around this context of developing appropriate learning models and then investigating how well they stand up to empirical observation. I'm going to be trying to throw out a few different resources for you so that you don't have to trust just my word on this. And so after you leave, some areas that may be interesting if you want to learn a little more about this learning engineering approach. Great article from Jeff Young from last summer in the EdSurge Moonshot catalog, easily findable via Google. And second, still fairly recent book from my colleague Justin Reich on the banks of the Cambridge River, Failure to Disrupt, which Charles River, excuse me, just botched my geography class there, who talks a lot about CMU's work in the broader context of where we've seen technology succeed and where we've seen technology fail in terms of fundamentally improving learning. So if you're interested, that's a place to take a look. But when we think about this learning engineering approach, one of the key areas for us is thinking about it as a broader set of tools. And so one of the projects that we launched about 1.5 years ago is an effort that we talk about as the OpenSimon toolkit. OpenSimon is intended to really take the best techniques, tools, content, and underlying code that can support this learning engineering approach and get them out into the community. And you'll notice that though this often gets described as an open source project, code is the last thing on this list. We think that the approaches and this instrumented content is pretty key to seeing this work succeed. So the tools that I'll be highlighting in this case are taking this set of tools, trying to move them into a more coherent but open ecosystem so that the tools make sense together, but also so that the underlying code is open and invite a broader set of participation, emphasizing an interoperability backbone so that the tools are able to better communicate and therefore encourage fresh participation and engagement. And so it's sort of in this spirit that we talk about this work and that we get very excited to see projects like the opening up of the data platform on your side. In this talk, I'm going to be noting 2 particular tools very frequently. LearnSphere is our educational data mining warehouse and analytics platform. It's intended as a place where we can share learning data, but also where we can share and refine approaches to analyzing these data sets. And the Open Learning Initiative. So OLI is a now 20-year-old research and production project at CMU that's emphasized building instrumented courseware that can enact learning, but that also provides a nice ground for experimentation. So a lot of that learning engineering approach as we outlined it. The last tool that you'll be hearing a little more about is OLI Taurus, which doesn't show up on my graph, but which is our next generation OLI platform. It's a platform that we're building out in the open and that we think is going to support a much larger population of educators in being able to build these kinds of adaptive courseware. If you'd like to learn more about Taurus, keep promising you outside resources, Michael Feldstein in his blog at eLiterate has done a lot of writing about not just the Taurus project as a piece of content, but how this fits into the larger ecosystem and where there are opportunities to join what's become not just a CMU effort, but a broader collaboration between multiple institutions. So opportunities to learn more. So we've got a learning engineering approach. We've got a set of tools and content that are going to be able to support it. What can we do with this stuff? And what's the framework that we want to approach this through? One lens that I like to prep folks through is this notion that this allows us to start thinking about learning design as a hypothesis. It's a phrase that I owe to my friend Dale Pike, now at Virginia Tech. And this notion that when we are engaging in learning design, what we're attempting to say is that we have a set of activities, a set of readings, a set of examples, videos, quizzes that we believe will result in a change of knowledge state. If we're able to state this as a hypothesis, this means that we're making this observable, we're making this testable, and this puts a certain set of requirements on us to engage in this as a hypothesis. Sort of specifically, it really does require this notion of instrumentation, that what we're capturing on the data side are learner interactions, not just at a clickstream level, but with a larger set of semantic context. What do I mean by semantic context? Well, it means that we're capturing some of the pedagogical intent and the design that sit behind our learning experiences, so that I'm not just throwing up a video or setting up a set of text, but rather I'm being intentional in saying, here is a worked example. And as the student reaches the end of this worked example, I have a problem for them that I intend for them to learn by doing. I expect them to make mistakes and I'm giving them appropriate feedback. At this point, I believe that the student should be able to demonstrate this skill on their own. And so I will have a practice activity that I expect them to do on their own, and the kinds of feedback that I provide is going to be appropriate in that context. So semantic context provides us with information about the underlying design of the learning experience. And when we pair that with information about what the learner's doing with the kinds of activities that allow us to evaluate their learning state, it allows us to do some interesting things. That data is able to drive feedback loops to our students, obviously. We're able to provide them with better targeted feedback, better hints, and better help. But it also allows us to start to drive analytics back to our faculty in ways that allow them to change their activities. To give you one example of this, this is a learning analytics tool that we talk about as the learning dashboard. This is a part of the larger Simon toolkit. It's embedded in OLI. The idea is that because we have behind the scenes a learning model for every student interaction inside of OLI, we have tied those student interactions back to skills, back to learning outcomes. Each time that a student attempts a question, we're able to make a prediction on what their knowledge acquisition has been. From a faculty perspective, I'm able to assign an OLI module before class, and then before joining the class, I can take a quick look to see what are the learning objectives that the class as a whole seem to be doing well, where are the areas where they're struggling, and where are there areas where much of my student body seems to still lack mastery. From there, I can drill down in these areas that are red, students that don't seem to be getting their mastery, and see what are these learning outcomes and what are the sub-skills that constitute those outcomes. I'm also able to drill down further to understand what's happening at the individual question level, what are the kinds of misconceptions students are showing, all of this in service of changing what I'm doing in the classroom. So I'm able to come up with a new set of activities that will hopefully address these areas where students are having challenges. Beyond, part of the reason that this works is that set of semantic context and the larger learning model that tie to these active learning activities. In this case, we do also have a deeper statistical model that's going to help us in making those predictions as students answer questions, and that will allow us to refine the model over time as more students engage with the content. As you can imagine, in the aggregate, though, this kind of information can also be very powerful as we start to think about improving course design. And that's the feedback loop that we want to be talking about for the rest of this session. So what are these tools and how do they help us in improving course design? And what's interesting is that if we think about learning design as a hypothesis, even before we begin putting this information in front of students, before we begin gathering our data, we start to ask questions like, is my hypothesis robust enough for testing? And so we have within the Simon toolkit a series of audit tools that can help you in understanding what are the skills and learning objectives that you are attempting to support. What kinds of practice opportunities do you have? What kinds of assessment opportunities do you have? And are these sufficient for us to be able to hopefully see whether your model's right, but also does this seem sufficient to give the student a good experience? And just to highlight the two on the bottom here, we've got 2 skills: make thinking processes explicit and base lessons on a cognitive task analysis. This is part of a course on e-learning design principles. So we get a little meta here. But what we're seeing is that for making lessons, basing lessons on a cognitive task analysis, students have no opportunities to practice this skill, but we've only given, we are testing them at least twice on a high stakes assessment. So this is an area where we probably want to go back and refine our design before we get students in front of these pieces of content. We've also been evolving these audit tools to try to give better guidance as we move into Taurus. And so you'll see we've got 2 types of audits on this page. We're able to run an accessibility audit, which I think is going to be pretty key long-term as the universities start really taking accessibility appropriately and seriously. We've got pedagogical audits, and this framework for auditing tools is going to allow us to keep on refining this so that even before we get information out in front of our students, we're doing our best to make sure that our hypothesis is robust enough for testing. But at some point, we need to look at how successful we've been. So we want to ask, does this model that I've built actually demonstrate learning? To that end, we have a set of tools that come to us from LearnSphere that we talk about as learning curve analysis. So I don't know how many of you have heard of learning curve analysis before. You'll hear a little more about it tomorrow from Ken. But at a basic level, what we want to do for a specific skill or a specific knowledge component is try to understand in the aggregate, for each attempt that students have at practicing this skill, how much help do they need, or how many mistakes do they make? So what you're looking at in this case, the first time that students practice this skill, on average, they need help about 50% of the time. Not surprising, it's the first time that they've seen this. But as the student engages in additional opportunities to practice this skill, they need less and less help. So that by the time the students are getting to the end of this learning experience, they're able to execute this skill on their own without hints, without getting the answers incorrect. So this is a perfect learning curve. It's a beautiful thing. This is learning taking place, validates the learning model. And in an ideal world, all of us that were designing instruction would be able to build a course and get a learning curve that looks just like this the first time out of the gate. Unfortunately, that actually doesn't happen for us very often. I say us in this case as OLI, but I also think all of us as educators tend to have more than a few misses. From a learning engineering perspective, this isn't ideal, but it's okay because we're committed to iterating on this. And so when we come back and take a look at our learning models, for this first skill, what we see is a very low consistent error rate. Seems like the students already know this and we're not making a very good use of their time. These next two skills are sort of interesting because in both cases, we start to see some learning taking place and then suddenly the error rate jumps up. Most likely what's happening here is that what we thought was a single skill is actually two different skills. We're suddenly springing something new on the student, and we probably want to tease those apart to better understand the learning that's happening. Finally, in this last case, we actually have a mystery that I haven't been able to solve, so I like to include it in all of our slides because without mystery, what would our lives be? But in practice, we have something that's happening as we add new activities to this skill about personally identifiable information that's causing real problems. So one of the first things that we do is pull our models into these learning curve analyses and try to identify where are we seeing successful models, where are we seeing models that have challenges. These also give us opportunities to think about other approaches. So if we were to just look at a learning curve on practice, in this case, the skill is express lists, and we can see a fairly nice learning curve. We would expect that students would do well by the end of the course in this skill. And yet, when we chart their high stakes performance, when we chart their high stakes performance, we can see that they're still having errors at a much higher rate than their practice would suggest. This starts to give us a theme for course improvement analytics, that they don't ever tell you exactly what the problem is, but rather what these kinds of analytics are going to do is give you a place to pay a little more attention, a place where you need to be a little more thoughtful and dig in to see where improvements need to be made. And I'll say that I think this is a fairly common theme in CMU's technology work, that we don't often see great success in replacing human beings with technology, but instead when we start to look for socio-technical partnerships, places where we can really help to leverage human intuition, we really see some of our best and most interesting work. We also have an additional set of tools that allow you to see where individual learning activities can be improved. Where are there places that things are problematic from a help perspective or from a participation perspective. And this same framework has given us the opportunity to invite analytic methods from other organizations and other partners. RISE analysis comes to us from a collaboration with Lumen Learning, the courseware provider based out of Portland that emphasizes OER and active learning opportunities. And what the RISE analysis allows you to do is take a look at per skill, average scores on assessments versus student use of resources. So they were looking at page views, but you can use different metrics as well, success on practice, number of activities attempted. In any of these cases, what we're interested in here is not necessarily resources with low use and low scores, which we'd expect if you're not using this stuff or not using it well, it's not going to give you a high assessment score. Similarly, if students are making a lot of use of a resource and they're succeeding in your assessments, don't touch that stuff, right? That's the place where things are working. But instead, these two quadrants where either we see students with high scores and low use, or worse, where students are trying to use your materials and they're still not succeeding. And so again, this is highlighting the skills and learning objectives where you really, as an educator or as a designer, want to spend your time. I like this analysis because it's one of the most accessible that we have, and it really is able to take advantage of existing learning data, even before you get into some of the fine-grained semantic context interaction data that I've talked about. But it does presuppose that you've done a mapping to your skills and learning objectives and to your resources. So at this point, I am going to turn things over to Erin, who's going to be able to give you some examples of this stuff in practice. Erin?
Yeah, thanks, Norm. Are you seeing my screen? Okay, great, thank you. So I'm really excited to share a couple of examples of how all this comes together and how we've used the tools and taken advantage of the instrumentation that OLI affords us. So let's dive in. So the first case I want to go through is from Carnegie Mellon University, where, as you may or may not know, Carnegie Mellon has a large cohort of computer science and engineering students. And we know that CMU is a challenging school, and we have these students coming in from various places, all over different high schools with varied math abilities, particularly in math theory and discrete mathematics, which are used very, right out of the gate in the majors of computer science and engineering. And so we weren't sure really where the students are coming in, what their skill level was, and these skills were much needed in their programs. And we had some data that also told us that some of these students struggle to hit the ground running in their first year as they attempt to catch up to their peers with this math theory and discrete mathematics topics. And these are things that are needed right from the beginning in their first courses. So OLI partnered with the Eberly Center for Teaching Excellence and Educational Innovation, which is basically our center for internal faculty support. And they came up with a solution hoping to level the playing field for these students, or any students who are coming in to these majors. And so they decided to design a short set of modules instrumented in OLI, providing self-paced, interactive material on these key prerequisite skills that we identified, and giving them to students before they come into their program. So we instrumented to inform on these skills, and these modules delivered lots of opportunities for practice, at the same time providing valuable data that we needed to understand the problem more concretely. And so you can see here, this is the list of modules and basically the outline for the course. This middle diagram is showing, or picture is showing how we broke down some of the skills and instrumented the content. And then on the right side here, just a few little exercises, just to show that we've put this together in a very thoughtful way, had a model in mind. And by the way, just for good measure, we also developed some introduction pages and targeted any issues with student motivation and wrote it in a language to support a growth mindset. So we were just covering all of the bases as we built this. So we delivered it in the summer of 2016. It was required by all incoming computer science freshmen. And not only did the results show that the course did help the students, the further discoveries we made with the data were priceless, if you ask me. These were the results on the first cohort of the course in terms of their post-test data. So you can see they're not doing too bad. I guess they could still use some practice and help with functions. And when we started to dig into the learning curves for individual skills, the data appeared to be even more nuanced, as you can imagine. So here are just a couple of examples of learning curves generated from the aggregate data for just 2 of the skills. And by the way, there's dozens of skills in this course. So this is just an example to show 2. And as you learned earlier, learning curves should generally look like this blue line here, where it's starting high and going down in a smooth line. And learning curves can show some things that we can't necessarily see with just the raw data. And for the one curve here, it doesn't look like any learning is happening on large formulae, and students are not improving with the skill over time. This one looks a little better, but there's some anomalies, as you can see, right before the 5th and 15th attempts. And so what this tells us is more intervention is needed. And that can take the form of adding more practice opportunities for given skills, building in more scaffolding in the form of more or better instruction, or breaking down those skills and providing further practice opportunities in finer grained skills. And by the way, these are just a few of the next steps that were taken on this content. So with the data that informed our refinements, we implemented more practice and feedback on targeted skills. We improved and better aligned the assessments and delivered again in the summer of 2017. And the new results got a little better. There was some improvement, but still a ways to go in our minds. So we iterated again. And this time, some data from subsequent courses was included and found that students were still struggling with some of the transfer of the concepts that involved open-ended problems. And so essentially students were getting into their major and their courses and still having problems translating some of this math theory and discrete mathematics. So to fix that problem, we added CTAT tutors. So this is instrumenting the course for more adaptive, more fine-grained data collection for each step in a problem. For students, cognitive tutors provide a practice in these individual skills. It's adaptive. The feedback is given with each step, and it kind of gives various paths to solving problems, and the feedback is provided all along the way. Again, just can't even say enough how much this iteration really is key. Looking at this data and improving performance over time, instead of throwing out the whole course and starting over, we can really dig in and find new ways to improve as we go. And when we delivered this next in the summer of 2018, this yielded kind of what I think are dramatic results. So you can see after seeing these results, we were impressed. We were glad that we were helping our students gain these skills. And in fact, our math faculty started to see that the CS students in their classes were doing better with the math theory and requested essentially that all of their students go through these OLI modules as well. Such as one example, and it's a longer term, over 3-year iteration process. But I have another example that is a little shorter term. So at CMU, we have this 5-day workshop every summer called Learn Lab Summer School. And it has tracks in OLI course development, building CTAT tutors, data mining, and computational models. And what we had a faculty member from Yavapai College, which is a community college in Arizona, come to our summer school to build an OLI module. And in this case, this was just last year, we had tourists available for folks to use. And he built a couple of really quick modules. His problem was similar to our computer science student problem in that he was looking to get students up to speed really quickly in foundational chemistry knowledge, like pH solutions and chemical equations. And this really was our first robust use of tourists, and it worked out really well. In the matter of 3 days, he put together these modules, and this is just an example of the modules that he put together. And what he did is he instrumented that content to provide a lot of practice and opportunities for students to answer questions. And we were able to get this course built and delivered to other participants at Learn Lab Summer School so we could generate some initial data, and kind of show this full loop. And so this insights picture is kind of showing just one example of in tourists how we show how we can dig into individual questions in a course to see how our students how they're working for our students. So we were able to do this quick analysis, and within the 5 days, turn around an iterated version of that content and really show off this iterative cycle. And he continued this cycle even beyond the summer school and continues to build out this course and deliver it to his students. And in fact, I often suggest that people start this way. Start with a few short pages of content, providing lots, a little bit of instruction, lots of interaction and practice in areas where you know that students are struggling, and start to use that data to improve and provide other opportunities for your students. And so it's a good way to start. But there's also other ways that you can work with us to jump into the world of learning analytics and the OpenSimon toolkit. And so I just want to show you some ways you can get involved. And I'll provide some links right after this in the chat so that you can get to these resources pretty easily. But you can partner with us. You can explore OLI and LearnSphere, very safe spaces to go in. We have ways where you can just go in and just start to build and start to play. Explore Taurus. Taurus is open and available for people to start building materials now. And you could attend an OLI webinar. We hold regular webinars weekly, at least monthly, to get you familiar with some of these techniques and tools. Or I highly encourage you to attend LearnLab Summer School, because it's a really immersive, fun experience, because you're not only in your track learning about, so if you come to the OLI track, you're not just learning about OLI, you're also learning more about the other tracks as well and getting to interact with those folks. Or we're always open to co-creating a specific workshop for anyone. We can do this with Unizin. We could do this for your particular organization. So I really encourage you all to just dive in and start playing with these things, talking to us, and I'll provide some links and our emails so that you can do that. But I think what we'd really like to do now is hear more from you guys about where you think, now that you've seen the types of data that we work with and the things we can do with it, where might you have some gaps that you want to fill in your particular organizations, or ways that, or things you want to learn more about?
Thanks, Erin. And I know this is a challenge, right? This is an awful lot of information late in the day on some fairly technical tools, and we hope that we did a fairly good job of giving you an overview, and at least showing you enough on the example side that you could start to imagine how this might be interesting in your context. But we'd love to also talk more about where there are some opportunities to close those gaps. I know that Ken in his keynote tomorrow will be mentioning that LearnSphere is really built not just to deal with the kinds of data types that we have, but to make it easier to pull in new types of data, new types of analytics. And so I think there may be some opportunities there to bring the types of data you're already working with to bear.
Mm-hmm. And by the way, there are already some very low stakes ways to interact with LearnSphere. There's places where you could even upload a grade book and start to see the impact of your class exercises on final grades, for example. Did we blow your minds? Did we talk too fast?
Well, we've got about 5 minutes. I think we were mostly on time. But I also think, I don't know about the rest of you, but the Zoom exhaustion is real. I'm simultaneously, like, I cannot wait to get back to some face-to-face meeting opportunities, but I'm also really confused and concerned about what it'll mean to breathe the same air as other human beings.
So we have a question here. How do you work with faculty to identify the types and sources of data that would be useful to challenges they identify?
This is a great question, because it drills down into organizational structure, really. And so within the Eberly Center at CMU, we have a team of learning engineers who are really trained to sit down and engage with individual CMU faculty to understand where are the challenges they're seeing their students, what are some of the existing sources of data, and then from there, how do we shift to either how do we use those existing sources of data, or how do we start to shift to getting data that are more robust. And an awful lot of that ends up involving, meeting faculty wherever they are. All right. So how do we drill in and see what are the assessments that you already have? What are the kinds of tools that you're already using? It helps that our learning engineers and instructional designers are really well versed in the kinds of tools that are already inside the ecosystem. And so an awful lot of this is trying to understand where are folks, what tools do we already have that might be an easy reach before we start making for a much bigger reach. The other piece of this, though, is often the benefit of the low-hanging fruit approach, frankly, is having a very fast turnaround for showing faculty the results of analyses. So, Erin just gave a great overview of a 3-year cycle, right? But for most of our faculty, they don't want to wait a year to see the value of these data. And so trying to identify some key opportunities to do rapid turnaround, even if it's with less high fidelity data, and then showing opportunities where greater use, different types of data are greater use of it. But an awful lot of this ends up being in sit-down consultations, sometimes with prior review of data that are already available.
And I would even say, instrumenting some of the content they already have. So taking a short set of exercises that already exist or an assessment and putting that in a place where you can collect the data at that interaction level really starts to show folks what's possible.
And I think that's been a natural set of work, but also a challenge for the Simon Initiative. I think we've been fortunate to have sort of represented on our Simon leadership team, Ken, who you'll hear from tomorrow, representing the scientific arm of Simon, but Marcia Lovett, who leads the Eberly Center and has really make sure that we're not getting so far out into theory that we're missing the fact that this needs to have real applicability to our educators and real applicability then to the students. So it's a lot of this has been intentional design and then the continuous communication with the Eberly team.
Yeah, and I'm happy if you want to reach out to me and talk directly about this. It's something I kind of do every day, is working with faculty to help them, envision their designs of the materials that they have into OLI.
Yeah, I'm going to throw my email address into the chat window in case. Oops,
it's in there.
Oh, you're ahead of me already.
Yeah, I added all the links for them.
I missed it.
You're very welcome. I'm glad you guys are enjoying the session. Thank you for attending.
Thanks. Hope we have a chance to talk more with you, and I hope the rest of the summit goes well. Looks like you've got some more interesting stuff ahead. So. All right. Thank you all.
Thanks, everyone.